Okay, recording and share screen here. Okay, so today we will we will move to the new unit. And I think on our course website it's called LinkedList. A very useful concept, okay. LinkedList. So it's a abstract data structure, okay. So it's a new data structure. And when we said data structure, we mean it can be used to store a collection of items. So just like, so far we have learned, so we have learned array, that, and we also learn array list. And we learned template, we learned generic, so we also understand this sign, that, and we also learn stack, that, and we also learn queue, that, and for stack, it's LIFO, that, so if you have some application that needs to be done with LIFO order, then you can use stack. And queue is FIFO. So if you have some application you want it to be done in order, then you can use queue. So that's their feature. And this can only access at the top. And for queue is you add at the back and remove at the front. That's its feature. And but anyway, both of them just some end. Either both end or one end. Array list, if you recall, its benefit is what? Is you can access at anywhere. Is it anywhere, but with what? With a specified index. The same for array, index position. Is it so quick access at anywhere? Is it not like stack and queue? It's not that easy. You need to remove certain number so that you can access something. But array list is anywhere. And because it's indexed. Okay, that's array list. And if I don't know if you have done with your lab or assignment. I remember in either your lab, and also in our slides, we also mentioned this. Who remember how to pronounce this? D-E-Q-U-E. And you remember in Q, we also learned this operation. How do we pronounce this? So what's the difference between these two? This is a verb, is it? And this is a noun. So how do we, so anyone knows how do we pronounce this one? D-E-Q-U-E and D-E-Q-U-E-U-E. This is what? This is a verb. It's pronounced. This one DQ. Is this. Which one is DQ?
The quake.
DQ is the verb.
Oh, verb is DQ. Yeah, very good. Yeah, very good. And how about this?
Deck.
Yeah, very good. This is deck. Yeah, deck. Okay, remember. Deck is what? What is deck? The fill in. What is a deck? I haven't completed the word. D-O-U What does that D represent? This D and this D are different. Is it? This D is a verb, root from the verb. This is different. What does that D represent? This is an abbreviation. So this is one word. This is another word. This is the root for verb, is it in English? But this DE is different. That DE is D and E. What is a D is and what E is?
Is D double?
Yeah, very good. D is double, very good. E is what? Double what, the question is here.
Double-ended?
Yeah, very good, double-ended. So this is double-ended Q, is it? Double-ended Q. So it has some similarity to Q, is it to Q? But it has Q performance on both ends, is it? So you can do add and remove at both ends, is it? If you recall, when we discussed the application different scenarios, is it? You need to use different data structures, is it? That's why we have all sorts of data structure, okay? Okay, so today's first question. Today's first quiz question is, you write down the complete name for this, for DAC. It's a complete name. Then you can send it to our chat. What a DAC is. Okay, you can write it down. DAC is what? Double-ended Q. Okay, double-ended Q. Okay. So, okay, so that's some review of the data structure we learned, is it? So today we will learn a new concept called linked list. So what is a linked list? So there is a keyword called linked. So far we haven't learned any data structure linked, is it? So far both stack and the queue implementation we discussed is using array. And we can see it's not very efficient because array has a fixed size, is it? And each time if we want to increase its size, we need to do array copy. That's a lot of work, is it? Okay, so linked list is what? So the concept is you have, so the basic unit in a linked list, basic unit is what? We call it a node. Okay, so what is a node? Visually, you can view it something like this. Okay, so this is a node, and it has information part, and it has a reference pointer to the next node. So it's built with these two parts. And information, so information can be what? It can be 1, 2, 3, those numbers, is it? Can be A, B, C, those letters. Can also be string, is it? Like a hello world, something, is it? Can be employee, can be account, anything. Is it? Even can be array, okay, can be a queue, is it? Whatever. Okay, so it can be anything, the information part. So then what is this next node you need? Okay, this next node, so this kind of concept, if you recall the railway, okay, the Amtrak, etc., it looks something like this. So you have a cart, then you have a hook, is it? And the hook going to hook to the next cart, is it? And then you have a hook to the next cart. And then it has a hook to the next cart. Then it has a hook to the next cart. That's a real way, real way. And then, okay, here is, then it's driving, is it? It's moving, is it? And once it's going to take all of the carts moving, is it? So here, each of this cart, it's a cart, is it? But it has a hook, is it? Hook to the next cart. So this next node, this is a reference type, is it? So this concept is kind of like the hook. It lets you get to the next node. Okay, let you get to the next node. Okay, so for a linked list, so basically it's built with a number of nodes. So you can look, you can view it something like this. Okay, then in our case, okay, suppose here we have 100, then 200, 300, 400, 500 stored in a linked list. Is it? Just like you store in an array or in an array list. Is it? Or in a stack or in a queue. It's similar. But here you store the number in its information part. And it's next. So here is its information. And here it's next. Its next is what? It's reference to the next node. Is it? To the next node. Okay, so here is the information. And here you have next. Is it? And the next reference to the next node. Is it? And then you have information, and then you have next. Is the next node. Okay, so that's what the next is it? So basically, this is a node. And based on what we have learned, so we can also define a node as a class. Is it? As a class. And then within the class, it has those two instance variables. Is it? Information. Is it? And the type we learned the generic can be T. Is it? And what? And the next. What is the next? The type is? It's a node. The type is a node. Is it? This is also kind of like the recursive concept, is it? But it's not recursive, okay. But anyway, it's a point to the next node, okay. It's a reference to the next. So that because of this, because of the next field, is it? So you can chain all nodes together. Is it? We chain all of these nodes together. Is it? Okay, we chain all of the nodes together. How do I identify this list, linked list? So basically, this is called a linked list. This is a linked list of integer type. Integer type. Is it? Okay, so we know this linked list, but then the question is, how do I identify this linked list? Is it? So if you recall in stack, you have the top index. Is it? And in queue, you have front and the back index. Is it? Those can be used to identify the stack and the queue items. Is it? And with a linked list, generally speaking, we want to have the first node. First node. So suppose you have the first node. Okay, set up. The first node, its information is what? Is 100 in this case. Is it? Let's see, in this case. And it has another field called next. Is it? It's next. It's next. This. Then who can tell me what's the type of first node dot next? What is the type? What's the dot next type is?
Integer type.
The next is what? Integer is store, the value. Okay, value, or we call contents, is stored in the information part. And a node is a class, basically. Okay, it has two parts, information part and the next. And we already know in this case, the information part is an integer, is it? And how about its next? What is the type? It's integer, it's a character, it's a string, it's an employee, it's account.
It is a node.
Yeah, very good. Okay, this is the type, is a node. Okay, so keep this in mind. It's a node. Okay, so this is our second quiz question. Okay, quiz 2. Okay, quiz 2, just write a node has two parts. What are the two parts? Information next. And the information, the type is generic T. And the next, the type is node. Okay, so can you write this? A node composed of information and next. And the information is generic type T. And the next is, the type is node. Okay, that's the second quiz question. Okay, so the next basically it's a node. Is it? So if you call it a node variable, is it? So this variable basically is the next. Is it? You can do this kind of assignment. Is it assignment? And how do you get 200? Okay, let's see. Let's repeat this list. Okay, so we have this linked list. So the first one, we have 100, then we have 200, then we have 300, we have 400, we have 500, is it? So this is our first node. We already know, is it? The type is node. Anyway, so it's a variable, is it? So node first, is it? Point to this guy, is it? And the first information part, we already know it's 100, is it? It's 100. And first next, anyway, is a node, is it? Is a node. And suppose we have a variable called node variable, and we wanted to point to the second node. How do I do it? You can do variable equals first dot next. Is it? Okay, so now my question is, how do I do system dot out dot print line? I want to output 200, the second node's information. How do I fill this part? Who knows, who remembers, or who knows how to solve this problem? I want you to output 200. Is it? For 100, it's easy. Is it? You do system.out.println first dot info. Is it?
var.info.
You say var.info. Is it? var.info. Yeah, that's correct. Yeah. And we can also, it's equivalent to us to write what? Can I write something like this? First dot next dot info. Is this legal?
I think you need some brackets. Braces for first dot next.
We can do this. Okay, of course, if you want to do this, that's also fine. Okay, but you can also just directly do this. First dot next. Because first.net is what? It's a node. Is it? And it implies at memory some object. Is it? So in heap, is it? It points to something here. Is it? And that thing, that memory block can be referenced by what? By this. Is it? By this. And of course, you can just do dot info. Is it? Then you will get its content part, its value part. Is it? Okay, so this is how do we get to the second node. So then my question is, how to get to third node? How do I get to the third node? Suppose 300. And assuming, so here is the game, okay? So the game won't let you, so you need to use the first. You can only use the first. Can only use the first to get to 300. So I'm going to write system.out.println. Println what? Yeah, we can do it. Anyone knows the answer? You use the first.
Can you use .next?
Yeah, of course. Yeah, very good. Okay, dot next is it? So this is dot next. This is another dot next. Is
And then dot info, right?
Yeah, very good. There dot info. Is it? Yeah, I can do this. Okay, then how about 400 there? Can you all? This is our third quiz question. Third quiz question. You write system data.println. I want you output 400. That's going to be your job. How do I output 400? So output 400. You need to do what? So system.out.println.
Add another .next.
Yeah, you can add another .next. Is it? And then .info. Is it? And you have fired .next. Is it? So just think about, okay, if you have first, of course you can access all of the remaining nodes. Is it? But you need to keep having .next. Is it going to be efficient? You have 1 million data stored, then you have 1 million .next. that's not going to be a good programmer. That so Google won't like this. That yeah. So, but anyway, through what we just discussed, for linked list, if we know the first, basically we know the whole linked list. Is it? We can always through first to get to all of the remaining nodes. Is it? So we don't need other information for this linked list data structure. You just need to know first node. That's it. Okay, so regarding this data structure, we just need to know first node. That's it. Okay, so that's the concept about linked list. Okay, so linked list. So linked list, the basic building unit is what? Is a node. Okay, a node has two parts, information part and next. And the information is generic. We are going to discuss how do we write a generic linked list. And next, the type is a node. That's it. Okay, so once you have this basic building unit, then we can use node to build our linked list. Is it just like the real way? Is it? And we have 100, 200 something, as opposed to 900 something. Is it? So then we only needed to know the first node. First node, is it? So the type is a node. And once you know the first node, you know everyone. Is it? You know everyone. Okay, so that's how a linked list looked like. Is it? So basically, it's a chain of nodes. Is it a chain of nodes via what? Via nodes next field. Is it? Okay, so this is the concept about linked list. They may ask, why do I need a linked list? Why just an array? Is it array list or stack or queue DAG? Is it we have learned? Is it okay? Then next, let's see the benefits of this. Okay, so for a linked list, so this is our linked list, 100, 200, and to 900, suppose, is it? And this, we only need first, is it? So here, linked list itself suppose also to be a class, is it? So you can define, of course, it's public, is it? Public class, linked list, is it? And we want defined as generic, is it? Okay, and with this linked list, then its data member is what? Is you will have the first, is it? And the type is what? Is a node, is it? So basically, you have this single instance. So this is instance variable. Okay, then we just show you know the whole linked list. Okay, so we don't need anything else. Okay, so that's the general framework. And then let's see. let's see, how do I get to each node? Is it, or here the concept is called node by node visit. Okay, node by node visit in a linked list, we call it traversing. Okay, traversing in linked list. Okay, what does that mean? That means you want to visit the first node, and then second node, third node. Is it just like this? Is it? And if you ever take Amtrak, you will know that if you want to get to the last card, you need to go through all of the intermediate cards. That there is no other way. You can just from the second card jump right to the last card. There is no way. You need to go through all of the intermediate ones. Is it? So this kind of concept, we call it traversing. Is it node by node visit? So how do we do node by node visit? Because each node has this next field. Is it? So that hook will lead you to every node. Is it? So generally speaking, then we cannot do first dot next, then dot next, chain that dot next. That's not a good way to write a program, is it? So here we can define some variable and we call it a cursor. The cursor's type is a node. Okay, so you can let the cursor start at first. Is it? You set it to point to the first node. Is it here is the first? So both point to the same memory location in heap. Is it? Then how do I move cursor to next? So you can set cursor equals to cursors next. Is it? So if you set cursor to cursor, now cursor move to the second. Is it? Move to the second. And it is, just think about it. If you put it in a while loop, is it? In a while loop, then here you can just, suppose we just want to do output, the system.print line. Then you can do what? You can just do cursor.info. Is it? And if I should move it here, is it? Then I advance the cursor to the next. Is it? Then I can keep doing. Then in this case, I can visit every node. Is it? Okay, but the question is, how do I know it's the last node? Is it the end of a linked list? Is it? So basically, last nodes next point to this thing, and we call this a null. Okay, a null node. Okay, so if your cursor is not a null value, is it a null reference, then you can always keep it doing. Is it? So last nodes next is null. Okay, remember, all of the other nodes, its next is not a null. Is it? So this kind of, so if we use this kind of loop, is it? That's called traversing. Okay, traversing. So that you don't need to write dot next, dot keep writing. Is it? That's not a good way. Is it an efficient way to write? So you just, you see, you update the cursor. This kind of concept, like in loop, we do plus plus. Is it? It's kind of like the concept. And also, if you recall, Previously, we learned the concept of iterator. Does you remember? So basically over here, this cursor is kind of like that iterator. Okay, the cursor can advance you. Is it? So here we call this advance to the next node. Okay, so how do you advance to the next node? Cursor equals cursors next. Okay, so this is the idea about the traversing. Okay, and then next, let's see. We still didn't get to the point why we need a linked list. Okay. Okay, suppose we just have this 5 nodes linked. Oh, this is 200, then 300, 400, 500. That's it. Okay, assuming we are going to assuming our linked list arranged in ascending order. In ascending order. Okay, so now what I'm planning to do is I want to insert 250 to the linked list. So how do I do it? So you want to have 250 insert in ascending order, then it should be between 200 and 300. Is it? So visually you can see, oh, I can do something like this. Is it? Because I need to store it in a node. I create a new node. New node. Is it? You create a new node. After you create a new node, then what? You can set the new node's next point to 300. You break this hook and hook it to 250. Is it? Then you get this 250 inserted between two existing nodes. Is it? And also in heap, because this is a linked way. Is it? So the first node, 100, is here somewhere. Is it? And the 200 maybe somewhere, and it's linked together. So they are not in consecutive memory location. Okay, they may not, it's just some random place. Is it? Because your memory card, it's consecutive. That's called consecutive. Is it? And they in the linked way. So that's why we call it linked way. It's linked way. It's just a memory block, but you have a reference to the other memory block. That's called linked way. Is it? And then you have 300 here. 300 here. Is it? And for this 250, then you see the benefits. Is it? 250 will find a available place. Is it? Then it let, okay, this point to here. Is it? And let 200, I'm going to reset its next point to this 250. Is it? So you won't touch those memory location. Is it? You just change next reference. Is it? Next reference. But if you think about, if you want to do array, if you want to have an array, 100, 200, 300, 400, 500. Is it? If you want to do array, then what you need to do? Okay, you need to shift of the items. Is it? Suppose your array has plenty of space. Okay, shift it. And then you have 250 maybe here. Is it? So it involves a heavy shifting. Is it? And in your memory location, it involves you shifting those values to different memory block. Is it? But you can see for linked way, then it's very flexible. Is it? You just reset the next. Reset next reference point. Is it? So that's why we have linked list. Okay, and also not like array, is it? Because in array, the size once you declared, it's fixed. Is it? And if you wanted to insert a new, then you need to expand, reshift, and recopy. Is it? So not as flexible as what we do here. Is it? And think about if your application has a lot of insertion. Is it? Then if you implement use array, then most of your efforts will be consumed on shifting. Is it? Versus you just find the spot and reconnect the next. Is it? So that's one of the reasons that why we have linked list. Okay, or we have the concept called linked way implementation. Okay, and for Java, it's not that obvious. Linked list, if we implement in C and C++, you will see the benefits a lot from the memory angle. Okay, okay, so that's all for today, and I think